Hello children, after studying Oersted experiment, then direction of magnetic line of force around a straight current carrying conductor, then magnetic line of force around a current carrying circular loop. Now let's increase the number of turns in a current carrying loop. Then we will see what happens around that. For that, we take a cylindrical tube. On that tube, we will wrap copper wire to make a helical coil. This is the coil made on the cylindrical cardboard tube or plastic tube. I will try to show you this activity in next video. So, and the 2 end of the coil will be connected to battery and switch. Battery and switch we connected the 2 end of the coil. Now the current through the coil will flow like this. Okay, we made a helical coil of copper wire and then we connected the 2 end of the coil with battery and switch. Now we take a magnetic needle near this coil. We see nothing happens with the magnetic needle. There is no change of direction of magnetic needle. Then again we bring some iron nails near this one. We see that nothing happens with the iron nail. Now we switch on the current in the coil. We find that the magnetic needle kept over here or anywhere near the coil gets deflected. Again something will happen, because if the magnetic field is produced around a straight conductor, around a single loop which carries current, then obviously we have increased the number of turns here. Long wire has been given the small space. Long wire given the small space. So what will happen? That the magnetic field produced around the long wire will get concentrated in a small space. Obviously, so what will happen? Magnetic line of force will get concentrated, will come closer, and then the strength of magnetic field produced by this coil will increase. Children, I know that you all would have studied this thing, but still I am explaining so that you can understand once it again. Now, what happens that through each turn, the current flowing is in the same direction. Through each, most important thing in this topic is that current flowing through each turn is in same direction. So what will happen? That the magnetic field produced around each turn will go on getting added up. 1, 2, 3, 4, 5, 6, 7 like that. And SI unit of strength of magnetic field is Tesla, not Tesla, Tesla. So if around one turn, 1 Tesla magnetic field is produced, so in 2, 3 turn will go on getting added up. So finally we will get a stronger magnetic field. We bring the magnetic needle here, it gets deflected away from the coil. North pole will or south pole will get deflected. That shows the magnetic field around the coil. If we bring iron nails near this one, they will get stick with the coil, but what will happen? That if we switch off the current in this one, iron nails will get detached from the coil. Magnetic needle will align itself like the earlier. So it will behave like temporary magnet. Which things we studied here? If we make a coil of copper wire, and then we connect the two ends of the coil with battery and switch. When the current won't flow through the coil, it won't behave like the magnet. But if current flows through the coil, it behaves like a strong bar magnet. And the stronger magnetic field is produced around this one. And reason behind that is what? The magnetic field produced around each turn go on getting added up, and finally we get the stronger magnetic field. And if we draw the magnetic line of force around this coil, the shape will be like this, inside the coil. As we had studied in case of circular loop, field lines will be like this. Field line are like this, and again, as field lines are there, magnetic field is there, so we will have to put arrow to show the direction of magnetic field around this one. Now children, if you try to understand, try to know, then it's better. Otherwise, what we can say, the end through which the current is entering in the coil will behave like the south pole, and other end will behave like the north pole, and you have to remember all these things. Now the direction of magnetic line of force will be this one, and inside the magnet this one, okay. So what we see, the uniform magnetic line of force inside the coil, these are circular loop, and the direction of magnetic field is being represented by arrow from north to south direction. The polarity of this magnetic field around the solenoid changes if the direction of current changes. Now again, to know the north and south pole, we use end rule. What is that? If the we represent the direction of current at this end, then direction of current is anti-clockwise here. We see from this end, direction of current is anti-clockwise, so this end of the coil will behave like north pole, okay. And at this end, if we represent the current, direction of current, then the direction of current will be this one, and this end will behave like the south pole of magnet, okay. So by this way, the two ends can be marked, which one is north and which one is south, okay. So this is the solenoid, and if we have to increase the strength of magnetic field around the solenoid, what we will have to do? We will have to increase the strength of current. We will have to use large number of turns per unit length. Means for suppose 1 centimeter, we will have to use maximum number of turns per unit length, and then decreasing the radius of the coil, diameter of the coil. Coil will have a smaller radius, so the field lines will get concentrated, and we will get a stronger magnetic field. So children, I think you would have understood the things we have studied in this topic. Solenoid, this is just a coil which behaves like a magnet on passing electric current through this one. It is temporary magnet. Field lines inside the coil are parallel to each other, representing uniform magnetic field. The end of the coil through which current enters in the coil will behave like south pole, and other end as north pole. We can use Maxwell's right hand grip rule, converse of that, to know the north and south pole of magnet also. Suppose if these wrapped fingers represent the direction of current, then the thumb will represent the north pole of magnet, direction of magnetic field. So the direction of current in the coil is like this. So this end will behave like north pole, and this end will behave like the south pole. I think this topic is clear to you all children. If you have any doubt, you can ask me. You can write message and you can ask me. I will explain once again. I can make another video for you all also. And I will try to show you this thing by an activity also, by doing of my own. Then till then you try to understand from this one. Thank you for watching and having patience to listen me, and also wait for the next video if you understand. Then thank you so much.